please pause the video and try to solve this on your own.
Welcome back. Let's now think through how we can solve this question. Now, first, let's think of the condition of non-increasing. Now, let's say we have an array. Now, we have an element at the index I and we have an element at index I plus 1. Now, if the given array is non-increasing, what would it mean with respect to these two values, right? We can say that over here, whatever comes over here has to be greater than or equal to what comes to the right of it, right? Only then it will be non-increasing. That means this value over here can definitely not be greater than what we have over here, right? Now, similarly, what is the case of non-decreasing? Again, we have an element at index I and we have an element at index I plus 1. Now, if it is non-decreasing, then whatever we have at I plus 1 can be greater than or equal to what we have over here, right? For example, now let's just take an example. I have two elements over here. Now, if I have 2 and 2, yes, I can say that it's non-increasing, right? And if I have, let's say, 7 and 1, in this case also I can say it is non-increasing. That is, when you go from left to right, you're sure that the value is not increasing. So that's what we can say about it in plain English. Similarly, over here also, if I have 2 and 2, it is still non-decreasing. And if I have, let's say I have 10 over here and I have 1 over here, right? Now, in this case, it's decreasing. So I should have something greater than this, right? So let's say I have 12 over here, 10 over here and 12 over here. Now, in this case, when you go from left to right, right, you can be sure that the value is not decreasing or it is non-decreasing. All right. So that is what we have understood over here. So we have understood what we mean with non-increasing and non-decreasing. All right. Now let's proceed. Now let's say we look at three possible scenarios. So I have three arrays over here. Now we look at the first element and the last element of the given array. So in this instance where the array which is given to us has 3 as the first element and 7 as the last element, right? Now this is the second case where we have 3 and 3 over here, and then we have 3 and minus 5 over here. So these are the three cases, right? I'm just writing 1, 2 and 3 over here. Now let's think through what we can identify in each of these cases when we compare an element at the ith index and at the I plus 1th index, which is the next element, right, in the given array. Now let's look at the first case. Now if the first element is 3 and the last element is 7, this array over here can be monotonic only if it is monotonic increasing, right? So it can only be monotonic if it is monotonic increasing, and for it to be monotonic increasing, it should be non-decreasing, right? That means as you go to the right, the value can either be greater than the previous value or it can be equal to the previous value, but it cannot be lesser, right? Because if it is lesser, then it's no longer non-decreasing. All right. So what is it that we can do when let's say we loop through the elements of the array, and if we compare array at I and array at I plus 1, we can be sure that if we find two values where array at I plus 1 is less than array at I, or the right element is less than the previous element, then we can definitely be sure that this array over here is not monotonic, right? So we can say false, right? Now, similarly, if we have, and again, remember, why are we checking whether it's false? Because it's easy, right? So the value has to be non-decreasing. We have seen that, right? Now, what is the opposite of non-decreasing? The opposite of non-decreasing is just decreasing, right? So that's why we are checking over here the opposite, which is decreasing. And if it is decreasing, definitely it's not monotonic and we can just return false. All right. Now let's proceed. Let me just clear this up over here. Now, what about the second case? Over here, we have 3 as the first element and the last element is also 3. Now, the only way for this array to be monotonic is if all these elements, they have to be 3, right? We have to get 3 over here and we have to get 3 over here and we have to get 3 over here. Only then we can say that this array is monotonic, right? If we let's say we have 4 over here and then 5, 6 and again 3, right? So then definitely it will not be non-increasing or non-decreasing, right? So the only possibility is if all of these are 3. So as we loop through the array, right, as we compare array at I and array at I plus 1, we just need to check if all of them are equal, right? So these two should be equal, these two should be equal, these two should be equal, and these two should be equal. Now, if any of these conditions is violated, then this array will definitely not be monotonic and we can just return false, right? So if all of them are not equal, then we can just return false. All right. Now let's look at the last case. again we are comparing the first element and the last element. Now over here we can see that the last element is less than the first element, right? So if that is the case, then this array over here can only be monotonic decreasing, right? And for this, for it to be monotonic decreasing, it has to be non-increasing. That is, as you go to the right, you should not get a value greater than the previous value. Now what is the opposite of it? You just have to check as you go to the right, as you compare these two, if you're getting a greater value, right? So as you check these values, as you loop through the array, if you see that the element at I plus 1 index is greater than the element at I, then it cannot be non-increasing or it cannot be monotonic decreasing. Therefore, it is false, right? So we have seen how we can solve this, right? So we just have these three possibilities. Now we are going to identify which of these possibilities is the case with respect to the array which is given to us, and then we are going to loop through the array and we are going to check whether it is false. Now if we are not able to return false, then we can be sure that the given array is monotonic. So this is how we can solve this question. It's pretty straightforward and pretty easy. The only thing is, like, we have many terms like non-increasing and monotonic decreasing, etc., right? So that should not confuse us. We understand that the only reason why it's saying not plainly increasing is because there is a possibility of two values to be equal. So you just need to factor in that possibility also. Now let's go ahead and look at the time and space complexity of this solution. Now the time complexity of this solution is clearly O of n, right? Why is that so? We're just identifying what is the case based on these three cases 1, 2, 3, and for that we just need to read the first and last value and compare them. That's a constant time operation. Now once we have identified whether the scenario is 1, 2 or 3, then we just loop through the array one time, right, to compare the elements at array at ith index and array at I plus 1 index, which is a for loop, right? So we're just looping through the array one time, and that's why the time complexity of this solution is of the order of n, where n is the length of the given array. Now what about the space complexity? The space complexity of this solution will be constant space, or O of 1, because we are not using any auxiliary space. Let's now get into the code for solving the monotonic array question. Okay, so first over here we are going to check whether the input array which is given to us does not have any elements. And remember, in the previous video we had asked the interviewer that whether we should consider an empty array to be monotonic, and the reply that we got was that yes, an empty array should be considered monotonic. So let's have a check for that over here. So I'll say if array dot length is equal to 0, so if this is the case, then we will just return true. Now if this is not the case, then we proceed with the remaining part of the solution. So as we've discussed in the previous video, we are going to first compare the first element and the last element in the array which is given to us. So I'll say const first is equal to array at index 0, and similarly I'll say const last is equal to array at index array dot length -1. Okay, so we have got the first and last element in the array which is given to us. Now what are the three possibilities that we have discussed in the previous video? The first possibility is the first element and the last element may be equal. Okay, now before we go ahead and fill the details for this, let me just over here construct the skeleton. Okay, so the first possibility is that the first element and the last element could be equal. Now if this is not the case, the other possibility is that the first element could be less than the last element. Okay, so that's again one more possibility, and if these two are not true, then the remaining possibility is that the first element is larger than the last element. Okay, so again we don't need to write that specifically because that's the only remaining case, right? So this means that first is larger than last. Now the way that we're going to approach this is that we're going to check whether the criteria needed for each of these cases for us to conclude that the array which is given to us is monotonic. So we are going to check whether that particular condition, which is the needed condition, has been broken, and if we can find that it has been broken or it has been violated, then we will just return false. But even after going through whichever the case is, if you are not able to return false, then we would come over here and we will just return true. Okay, so this is the skeleton of the approach. Now let's go ahead and fill in the details. If the first element and the last element are equal, we would need every element in the array to be equal for it to be monotonic. So what we're going to do is we're going to iterate from index 0 till the last index of the given array, and we are going to check whether array at index I plus 1 is not equal to array at index I, because if that is the case, then the required condition has been violated and we will just return false. So over here I'll say for let I is equal to 0, I less than array dot length minus 1, and we have I plus plus, and over here I'm going to say if array at index I plus 1 is not equal to array at index I, then we will just return false. Okay, so again we are checking whether the required criteria has been violated, and if we find that this is true, we will return false. Okay, now let's proceed. Now if the case is that the first element is less than the last element, then again we'll have the same for loop. So we'll have for let I is equal to 0, I less than array dot length minus 1, I plus plus. Okay, and over here the needed criteria is that array at I plus 1 has to be greater than array at I. Okay, because the first element is less than the last element, or the last element is greater than the first element. So we are going to check whether that criteria has been broken. So over here I'll say if array at index I plus 1 is less than array at index I, so if this is true at any instance, then we will just return false. Okay, and finally we'll have to do something similar over here as well. So over here the first element is greater than the last element, so we would need array at I plus 1 to be less than array at I. So we'll see, or we will try to check whether that criteria has been broken, and if we find that it's broken, we will just return false. So again I'll say for let I is equal to 0, I less than array dot length minus 1, I plus plus, and over here I'll say if array at index I plus 1 greater than array at index I, then we will just return false. Okay, so that's it. Now if we were not able to return false, then over here we'll go ahead and return true, because the array which has been given to us is in fact monotonic. So this is the solution to the monotonic array question. Now let's go ahead and run this code and see if it's passing all the test cases. And you can see that it's passing all the test cases. Okay, and again do make use of the user logs. It will help you debug your code in case you're stuck at some point. Congratulations on completing day 1 of the course. You've taken the first step towards mastering data structures and algorithms, a crucial skill for top tech interviews. Today, you tackled arrays and big O notation, setting a solid foundation for what's to come. Remember, every great journey begins with a single step, and by starting this course, you're already setting yourself apart from many others. Keep pushing forward, stay consistent, and you will see incredible progress. You've got this.